Welcome to clickmyproject.com. Let we discuss about the process computer aided bleeding detection in wireless capsule endoscopy video WCE videos. Let me see the abstract of the process computer aided bleeding detection in wireless capsule endoscopy video. To find bleeding present in the wireless capsule endoscopy video, we use superpixel segmentation and classification based on support vector machine classifier. In the process, the initially video is pre-processed by converting the videos into frames and removing any of the unwanted pixel information in the video. The size of the video frames varies depending on the video format and the file format that we are proposing. The video is read and the median filter is applied for the unwanted noises removal in the videos. After that, the smoothened images, which is the result of the median filter, is then used for the next process. The edges were detected using canny edge detection methodologies. The canny edge detection is an edge detection operator which uses a multi-stage algorithms to detect wide range of edges in the images. Initially, Gaussian blurs were applied in the images in order to eliminate the unwanted edge informations in the images. Then gradient operators were employed to find the gradient intensity and the directions. Non-maximum suppression determines if the pixel is a better candidate for the edge than its neighbors. The edge detection process, the first derivative in the x and y position of the pixels obtained. Edge detection angle is rounded to one of the four angles representing vertical, diagonal, and horizontal components. Dilation operation uses a structuring element for probing and expanding the shapes contained in the input images. The image is dilated, then the coordinate points known as the structuring elements were employed for the dilation process. The dilation of the images produces a binary image in which all the locations of the structuring element were of combined, and if it hits the particular zero positions, then it replaces all the pixel coordinates. Dilation has the opposite effect of erosion. It adds a layer of pixels to both the inner and outer boundaries of the regions. After morphological dilations, seed region growing based segmentation is employed. The superpixel segmentation balances the complexities through the pixel grouping. The initial seed point is grown in order to obtain the similar pixels in the image. For this process, a particular threshold value is assigned for different video frames. The nearby regions were combined by identifying the similarities of the pixels. Then finally, classification is employed using support vector machine to identify whether the samples contains bleeding or not. So for the classification, the features were extracted based on the statistical parameter. Finally, the performances of the processes were analyzed in terms of sensitivity, specificity, and accuracy. Let me see the flow of the process. In this process, the video is taken as the input. The videos were converted into frames. In this frame conversion, different videos have different frame length and different frame width, and based on that the conversion is employed. After frame conversion, pre-processing steps were employed. In the pre-processing step, the basic pre-processing steps like filtering were employed. After that, the detection of edges is employed using canny edge detection methodology. So in this, the regions that were affected outlines were obtained. After that, the segmentation is employed based on superpixel segmentation. While segmentation, the thresholding based regions initializations were employed. So for each video frames, the threshold regions were defined. After that, the classification is employed using the support vector machine classification. In support vector machine, we extracted feature values from the regions, which is based on the statistical parameters estimated from the video frames were given as the input for the support vector machine classifications. The features were classified into normal or bleeding detected based on the kernel function that is designed in the support vector machine. More commonly, linear kernels were employed in the vector machines. After the classification of normal and on bleeding detection, the overall performances of the processes were identified. The overall performances were identified based on sensitivity, specificity, and the accuracy of the process. While the bleeding detected regions, the detected bleedings were segmented based on application of the thresholding operations, which differs on each images. Let me see the running procedure of the process. If you want to run the code, select the file main1.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface to run the program. So this user interface contains the buttons and the display accesses for running our process. So first we select any one of the video which is presented in the dataset provided by us. So this process is a trained process, so the process will work for the videos that is provided by us. So the videos in the dataset were selected and it is displayed here. So after the video is selected, the location of the video is displayed here. Then the frame conversion process is applied. So while frame conversion, the videos were converted into frames based on the frames height and width, which is calculated while reading the video. After that, the pre-processing step is employed, which is based on the basic filtering processes using median filter. After that, the edge regions in the videos were detected, which is employed based on the canny edge detection operator. So in this process, the regions in the images that contents of the interested overall edges were identified. So based on this, the further processes, the identified pixels were selected. Then after that, dilation process is employed. While the dilation, the selected regions in the previous edge detection methodologies were well identified, and based on that, the overall identified regions were increased. So this will help in the searching of the complete video frames for the detection of the portions in the video frames. So after that, the edge removal process. So in the edge removal process, the input frames were combined with the detected edge regions in order to identify the final edge pixels that is recognized in the images. So this final edge pixels consist of all of the necessary edge regions that is to be used for the further initialization and the superpixel segmentation processes. So the superpixel segmentation initialization is employed, which is based on the comparison of these detected edge regions with the original images and placing these edges in the original images. So the detected regions were placed in the original image, and based on that, the regions in the images that is to be used for segmentation is initialized from the images. Hence the regions that is to be searched in the overall video is reduced using this process. So the white regions were matched with them, and they were superimposed over the input video sequences, so that we can identify the needed portions in the video frames. So this process will take some time for execution. So after the completion of the initialization of segmentation, superpixel segmentation is employed. So as we can see, the detected regions were obtained here, and the regions were segmented using this superpixel models. The small regions were identified, and based on that, the segmentation is employed. So after that, the features were extracted from the images, which is based on the statistical parameters extracted from the regions. So these statistical parameters were given as the input for the bleeding detection process, which is employed using the support vector machine. So in this process, when the bleeding is detected, the results were displayed here. So for each bleeding detected frames, the results were displayed, and for each bleeding detection, the regions were segmented based on the application of the threshold presented in the overall regions. So as we can see, the regions were segmented based on them. So and this segmented portions, while the tumor regions were identified. So finally, the overall performances of the process is measured. So as we can see, this is the confusion matrix, and this is the receiver operating curve obtained, and this is the overall performances obtained using the proposed methodology. Thus, we have identified the bleeding detected regions in the wireless capsule video, which is based on the SVM classification methodology and the statistical features extracted from the images. Thank you.